Back, everybody. I'm going to proceed and start on the L's, and we're going to skip a bunch or go through them really quickly because we've already looked at them. Again, the last function takes an array and gives you the last element of the array. We don't need to go any further than that. Our last index sub function we looked at in the very first video I did in this series with find. We find the last index. We take a value and a list that contains that value, and it tells us what index it's at. So 0, 1, or the last index, sorry. So 0, 1, there it is, 2, there it is, 3, 4, 5, 6, and that's the last occurrence. So without this function, you could reverse the list and then do index of, and that would do the same thing. But that's not as performant because you've got to flip the list first. And then if the element that you're looking for does not appear in the list, you get a -1 instead of undefined. So that's all that does. Length is super simple. You give it a list and it tells you how long the list is. Um, in native JavaScript, here's a list of 1, 2, 3, 4, 5, an array of 1, 2, 3, 4, 5. And if I do r.length, you get 5, and I do. So this is a function, and in built-in JavaScript, the length is a property on the array prototype. So you would do length like that. That would give you the same thing. So just for fun, if we did d.list, which is 1, 2, 3, 4, 5, and we used the r.keys, we get 0, 1, 2, 3, 4. These are the automatically generated keys for an array. But if we did keys in, which we just looked at in the last video, oh, I thought we would get the list, but we don't. I thought it would look up the prototype chain and show us that we had a length property, which would be a key, but we don't, and that's okay because we don't really want it. That would be super annoying if it always existed. But anyway, that's length. Length is just a function instead of a property. I think in PHP it's called count, and it's also a function. And I feel like it makes more sense as a function. Um, I almost wish they would just give you both in JavaScript, but they don't. But we have Ramda, so we don't need it. So that's length. And in the last video, I explained that I'm going to skip the four functions about lenses because they deal with functors, and I don't feel like I'm in a position to explain functors, which aren't too complicated, but I'd rather get back to it. And then there's several C others, and I do know a lens is basically it allows you to zoom in on a section of an object, and then it gives you a setter, a getter, and a setter for those objects, um, which I presume would return a copy of the object that's changed instead of, we're not going to mutate the object because we just don't do such things. So there's lens, lens index, lens path, and lens prop. And again, I will go through those at some point when I feel like I can speak about them intelligently. But we'll pick up on lift and lift in. And I haven't even looked at these. I have no idea what they do. So I'm going to give it a go and we'll see what happens. Let me just clean up. Okay, so lift. Lift is one of these functions. It takes a function and okay, so the star dot dot dot. I mean, that means anything. Yeah, okay. So instead of just saying A, comma B, comma C, comma D, ellipses, this means that like it could take four A's, it could take an A and a B, it could take two A's and two B's, just whatever, but variadic. And then it can return whatever. So it's literally just a function. And then it returns a function that takes a list of anything and then returns another list of anything. Let's expand this. The function to lift into the higher context. Well, that sounds like um um the function to lift into the higher context and it returns the lifted function. Okay, so that raises more questions than it provides answers for. It lifts, in air quotes, a function of arity greater or equal to one, so no unary functions for some reason, that it may map over a list. Oh, it can map over a list, function, or other object that satisfies the Fantasyland apply spec. Okay, so in the previous version, we looked a little bit. I mean, we could look at it just briefly. Apply. So we have a functor and a more specific, like I think a functor has a map method, right? So a list is a functor, an array. Array has a map method on it. So anything with a map method is a functor. Look at me explaining the Fantasyland. But if you go down these dashes, it branches off. The apply is also a functor. It has a map, but it also has an app method. So let's click on that. So apply is a value that implements the apply specification. Or I'm sorry, yeah, a value that implements the apply specification must also implement the functor specification. So that's why I just said. And then it has all this business. I don't know what this means. But the app method, it is yeah, the app method of the Fantasyland specification has a type constraint where F is an apply. So and I guess the F is a functor. So it takes a functor of A's, and then it takes a functor of a function that goes from A to B, and it returns a functor of B's. The value which has an apply must provide a Fantasyland app method. Fantasyland app method takes one argument, which is a B, and that would be like our list of B's. Or maybe it's not a list. It's a functor of B's, so it probably a list. B must be an apply of a function. So if B does not represent a function, the behavior of app is unspecified. B must be same apply as A. So within the same category, I think is what that means. So if B is a list or an array, then uh, or if A is a list, B must be the list too. A must be an apply of any value, so it doesn't matter what values are in the list. App must apply the function and apply B to the value and apply A, which means no parts of return value of that function should be checked. I don't know what that means. The apply returned by the app must be the same as A and B. Okay. So that didn't really help me understand this any better, but just having read it, maybe some of this stuff will click into place as we experiment. And go back here. Let's look at the, yeah, we already looked at that. Okay, so let's look at the code examples and reverse engineer. All right, so we have a MAD3. I don't know what that stands for. MAD3. Oh, add 3. And the M probably stands for like monad or monoid. Again, part of the Fantasyland apply spec. This all comes from category theory. But we're taking 3 arguments. So lists a function of arity greater than or equal to 1. So this function that we're providing here, this whole function, has an arity of 3, and it adds those numbers together. So let's try it. Okay. So what it's doing, we're taking 100, adding it to 30, adding it to 5, and we get 135. Then we take 100, add it to 30, and add it to 6, get 136. Then 130 and 7, we get 137. Then 145 there, 146, 147. So it's like adding every combination of these numbers together. We have 2, 4, 7 numbers. We have 4, 8, 12. So trying to think of what the math would be to calculate how many possible answers we have, and I'm not quite sure. And then if we do this 1, 2, 3, 4, 5 lists, we get the same thing. Okay, so how is this working and why is it useful? It lifts a function so that it may map over a list. Okay, so we are mapping over. We're taking the first value here, the first value here, the first value here. So that's A, B, and C, and then we add them together, A plus B plus C. Then we take the first value and the second value and the second value, and then the first value, let's see, actually, 1, 2, 3. And then on the fourth one, we take the first value, the second value, and the first value. Yeah, so literally it's taking every combination and applying the function. So, it's changing what the A, B, and C is every time we map over. So it is like an iteration function. It loops. Yeah, this is interesting. So it does loop, but I mean, if we had to do this without the lift function, how would we even do it? We'd have to use reduce, and it would be really tricky. I'm not even going to try it because we would have to somehow keep up with how many elements are in each array. Yeah, so I mean, if somebody, if like, if I had a boss or if I had a client that said, I want you to do this, and I didn't know about a lift, I don't know how I'd go about doing it, to be honest with you. I'd probably try to restructure these values into like an object or another array and map over that, or do something recursive. So yeah, I mean, if you're dealing with a lot of data and you're making a lot of reports, this is extremely useful. I wish I could think of another example where we're not just adding numbers together. What if I did hmm, something with a string? What could I do with a string? I can cat. I use the same naming convention. Cat 3. And so what we would need to do is say a dot concat. Well, no, r dot concat a. Trying to think of the order. A with B. They wrap that in the concat with C. And then I'm going to use the same structure. So we have an array. We have three arrays. The first have two elements and the last one have three. I could say dog, cat, apple, banana, Lando, Lewis, and Oscar. What will that do? Probably an error? Nope, that works. Yeah, so dog, apple, banana, dog, apple, Lewis. No, dog, apple, Lando. Sorry, I can't read. Dog, apple, Lewis. It's doing the same thing. So it lists a function so that it may map over a list. And so I guess what's the question is, what do they mean by lifts um, in double quotes? Not 100% sure yet, but I do understand how this works. But I don't know how much farther I can go with this. I mean, it's useful when it's useful, and I feel like there's this underlying theory here that I'm missing. But this is what happens when you just go at it from scratch without any previous research. But we can all do our research on our own. And I feel like at some point I'll go, oh, I get it, lift, and then I'll understand the underlying point with all this. But for now, let's just move on to lift in and see if we can make more sense of this. So here we've got this function that takes anything to anything. So that's like our map function. And then it returns a function that just, oh, I get it now. See, just takes a second. What we're doing is we're taking a value and lifting it into an array. That's what the word lift means. By lifting it into an array, like a functor, we're able to always compose arrays together. Like we used a pipe, an array will, takes an array and returns an array, and the next function takes an array and returns an array. You never have a problem with the two functions fitting together. Like if you had a function that returned a string and the next function took a number, that would be a problem. But if we lift the raw value, the scalar value, into a list, that list is a functor, and then we can do all our stuff inside of that and return it. And then we can pull the value out of the list when we needed to. Maybe we pull the value out of the list, we do something to it, and then we stick it back in a new list. That's the whole idea with this. Um, and I'm not sure if when I say lift, am I lifting or just a value into a list, or am I lifting it from the list out? That might be what it's doing. So I'm not sure, but just from the signature, it told me a lot. I mean, the signature of this function is the same as this one, except these values are not in a list and these values are. And of course, we take the function and we return a function and then we call that function, or we apply this function here to a value or some values. So I'm getting a little closer. Let's check out lift in and see if it makes more sense. So the same exact signature here. Yeah, same thing, except we have another argument that goes before it, and this is a number. These are both added at the same time to Ramda, zero point 0.7. Oh, look at that. I think this is a bug. They forgot to add the parameter for number. I bet they just copied and pasted function to lift into higher context, the function to lift. Yeah, I think that was copy pasta mistake. Function to lift in the higher context, and it returns the lifted function. So what that says, returns the lifted function. I want to be able to see the difference. So lists a function to be specified, sorry, lists a function to be the specified arity. This one lists a function of arity greater or equal to 1. So that's the difference between these two so far. So that may map over that many lists, functions, or other objects that satisfy the apply spec. So that it may map over that many, so that it maps over a list. Okay, so we just tell it exactly how many things to map over. Um, let's take their example and run it. We'll need to log it. And we get this. So here we tell it to lift in versus this last one where we just provided the arguments and it can tell. It says there's 3 arguments, so it knows the arity. Here we tell it the arity is 3 and we say sum the args. And that's the exact same thing as we did on the last one. So we get 1, 2, 3, 1, 2, 3, 1. So 1 plus 1 plus 1 is 3. 2 plus 1 plus 1 is 4. 3 plus 1 plus 1 is 5. We're out of that one. So then we move to the next argument of the first list. 2 plus 1 and plus 1 is 5. Wait, 2 plus 2 plus 1. So where did we get 4 from? 1, 1, 1 is 3. 2, 1, 1 is 4. 3, 1, 1 is 5. 3, 4, 5. And so the next one should be 4. But we should be starting. Oh, 2 plus 1. Yeah, 2 plus 1 is 4. Yeah, I get it. 2 plus 2 plus 1. Actually, next one should just be 2 plus 2. I guess we're done with the 2. So then we move to the 3. Yeah, it's hard for me to keep up with it because there's less ones, but I think you understand. So if we did this last example, and we never looked at this one, but it's the same thing. It just has 5 arguments instead of 3. But if we use these arguments, would we get the same thing? Yeah, that was the same thing as we got before in the last example. So the difference, I guess, is we're specifying the amount of arguments. And what I'm guessing is that if we had another argument, like a fourth argument, and then we ran this with the same thing that expects 3, will it ignore the fourth argument? And no. So, but if we said 4, this shouldn't crash. I thought it would just ignore it because it's JavaScript, but it doesn't. So this is when you want to control how many it needs. So if we gave it one less, yeah, we get a function back that would need the third argument. So that's the difference, it looks like. Um, and it does say C app, and we've looked at, or app was part of the first series that Chris did, but it's been a long time. It's been like 8 years now. So we'll go and take a look at that. Yeah, let's take a look. See how they're similar. Yeah, I remember now when he was talking about that because he went in and I think we looked at the Fantasyland spec because there's a type constraint on the type variable f, which is an apply. It has those required functions that we looked at, but it takes a list of A to B, an A and a B. Yeah, so in human words, we pass it a list of functions. So multiply 2, add 3, and then a list, and we get back 2, 4, 6, 4, 5, 6. So it's multiplying 2, 1, 2, and 3, and we get 2, 4, 6. And then we add 3, so we get 4, 5, 6, 4, 5, 6, and it puts it all in one array. It's a little bit like Juxt, where we're applying multiple functions to the same thing in the list. It's almost just like Juxt, isn't it? Hmm. But it doesn't say see also Juxt. But I mean, now I gotta look. get rid of that. Okay, 246456. And then if we did log r.juxt and we pass the same list of functions, oh, I see. Well, no, yeah, I mean, we take the same amount of functions and then like the same list, one, two, three. We run both of these. Aha, Juxt returns a function that takes these arguments. App applies these functions to these arguments. How does it know? Oh, because it's an array of functions, two arguments, this argument and this argument. So the functions and the data. The apply is like the one of the most common functions in functional programming because we apply a function to a value. Here we're creating a function and returning the function, and then we can apply the function to the value. But we're not. The Jux doesn't take an array, Jux takes a list of values. Oh, but it's applying multiply to this one, and then we get two back, and then it applies three to the second argument. No, it's not. It's saying multiply two times one, and we get two. Multiply two by two, and we get four, and then it just stops because we have two functions and three values. That's interesting. So they're really not related, and I might have to go back to Juxt. I guess I should. Takes an array of functions and it returns a function that returns a list of values after applying each of the original functions to its parameters. So maybe it's that multiply two takes two arguments. We provided one, and here's the second one. But it's like, why didn't it apply add? Hmm. Because what I was expecting would be, yeah, I don't know. Don't know. Yeah. And sometimes you just don't know. All right. So that was lift in. And again, a little bit complicated. Let me keep going uh, just so I can end off on some functions that I understand. And we've looked at less than before. We looked at greater than equals. It takes two numbers and returns a Boolean or two things that can be compared. They're two things that are orderable. And so that's what this type constraint means. Um, and I had a hard time, but again, let me just throw this out there because it helped me. When I say less than three and two, that's the same thing as saying three less than two, because we're doing this as a prefix operator, um, like a normal function. it just looks strange because, like, am I comparing if three is less than two or if two is less than three? What we're saying is three less than two. Um, and we should get false if I remember that correctly. And need R. Yeah. Three is not less than two. And then the equals version. And again, we'll get false. But if we made this in three, we'll get true. And if we made this 32, we'll also get true because three is less than or equal. Whoops. There we go. And we get true as well. So that's less than equals. Uh, Here where you can also compare strings instead of just numbers. Strings are orderable, where A is probably greater than Z or the opposite. I don't know. Um, that's probably useful for writing a sort function, right? And then less than equals. So, and it says C otherwise greater than or equals, but we've looked at that. So that takes us through the else, and then we'll pick up on map. Let's take a look real quick and see what we're in for. Got map accumulate. So a bunch of different versions of map object indexed. Then we got match and math mod. That's interesting because there's a modulo that'll be in here. We got max by mean, median, memoize with. Wow, a lot of them. A whole bunch. Lots of merges. One, two, three, four, five, six, seven, eight merges. Min, modify. Wow, there's a lot. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 28. 28 maps. But then when we get through the M's, we'll be halfway through the alphabet. And as I scroll and I see my little scroll bar thing here, we're slightly halfway through the list of Ramda functions. And we've also done a lot of C alsos. Um, so we'll be really making some progress once we get through that, but it's going to take some time. So we'll pick up in the next video with map. Thanks for spending more time with me. Uh, Tell a friend, and then I'll see you in the next video.